Hello everyone, welcome to FA Learning. Today I'm going to talk about centrifugal pumps. It's just a basic video regarding the working principle and the basic components of the centrifugal pump. So let's begin now. The definition of the centrifugal pumps, right? A pump in which the pressure is developed principally by the action of centrifugal force, right? Now you must know the centrifugal force. If there is round object and some having some velocity at that location, we experience some the centrifugal force. We learn in the physics, right? The basic in the college and in the universities. The same one we are discussing here. The same concept we are using to pump the liquid at high pressure. So basically centrifugal pumps transport a fluid by converting rotational kinetic energies, right? Those energies coming from the driver and the shaft to the hydrodynamic energy of the fluid flow. Basically speaking, kinetic energy of the moving fluid converting to potential energy, right, at the end of the discharge. Okay, so here we have different component of centrifugal pump. We have the casing which collect the water and deliver it to the discharge. Then we have the impeller. These are the impellers, right? These impellers use centrifugal force to move water, right? And these are the eyes of the impellers and the vanes. These are the vanes, number of vanes and all. The more number of vanes, different properties and all. So as the vanes, it's adding velocity to the waters, right? So it adds a velocity to the waters while rotating with the shaft, rotating with the impeller. And then we have the volute, right? Which captures the velocity of water as it enters the outermost diameter of an impeller and converts the velocity of the liquid into pressure, right? So in the volute, velocity converts to the pressure. Basically talking kinetic energy change to the potential energy, right? So here we have the working principle, right? How it works. We discussed that one because we discussed in the beginning. A centrifugal pump consists of an impellers which is connected by a shaft to a driver, a motors or any kind of the driver, and from that they gave the energies to the impellers, rotational kinetic energies, and those rotates the impellers. Because of that one, liquid is forced into the inlet side of the pump casing by atmospheric pressure or some upstream pressure, which is like if the tank is at some elevated height, we have some net positive suction head, right? The one we discussed in my previous videos regarding the pump head definition. I recommend you guys to see that video also along with that one to understand the different concept of that one, right? So once the liquid reaches the rotating impeller, the liquid entering the pump moves along the impeller vanes, right? It moves along the impeller vanes, increasing in velocity as it processes. So as it goes there, the velocity increases, right? And when the liquid leaves the impeller, vane outlet tip, it is at its maximum velocity, right? So at the outlet of those vanes, the velocity is maximum in the centrifugal pump, right? And after the liquid leaves the impellers, it enters the casing where expansion of cross-section areas occurs. Now this cross-section area play a major role to convert the kinetic energy of the fluid to the potential energy or hydrodynamic energy, the one we discussed in the basic definition. So last point I want to cover here. When the liquid comes at this point, right, look at this areas, right? This area is very small compared to this areas, right? So as we can see, we have less areas. So at that location, we have velocity is high, but pressure is low, right? So we can say when liquid enters into the pump, it's having high kinetic energy in the impellers. The tip of when the liquid leaves the impellers or the vanes and all, the liquid has high kinetic energies. Now all those kinetic energies convert to the potential energy while going at the pump discharge plant. So area, we have less area here, so velocity is high and pressure is low. So let's say kinetic energy equals to, if you know the basics, half m v square, right? So we have the high velocity, so high kinetic energies, and less potential energy, right? We also know the conservation of energy at At one location kinetic energy is high, at another location potential energy is high, so it is conserved, kinetic energy converted to potential energy, right? So at the outlet of the pump we have potential energy highs and kinetic energy low. How it happens? We can see at the outlets the area is much more higher than the inlet, right? And we know that one. When we have higher diameter pipe, we have less velocity and high pressure, right? So this is how it happens. When the liquid enters in the casing, right here, in the volute, right, liquid enter in this areas, we have less areas, so we have high kinetic energies and less potential energy. As it passes through the pump to the top of the pump, I think nearby the discharge, right, the area is maximum, and if the area is maximum, now it is reverse, velocity is low and pressure is high, we can say kinetic energy is down and potential energy is high. So all of the kinetic energy is converts to the potential energy at this location. This is why we are getting more head and pressure at the end of the pump discharge flange. That's all about centrifugal pumps. I hope you got the basic idea of the centrifugal pumps. Still you have some questions regarding this, you can contact me through those channels available here. So I will see you next time, and please subscribe my channel so that you can get the latest update and various FE topics. Take care, bye bye, and take care.